In this question, we're going to find the mass of a person who experiences a force of gravity of 281 newtons on the surface of Mars. So here's our diagram of a person of Mars, and we're given a couple of pieces of information, really only one in the question, and then others we need to go and find. And first of all, we've given the force of 281 newtons, and then we're going to be using this equation right here, which solves for gravitational forces exerted between two objects, and our two objects is the man and Mars. And so big G right here is our gravitational constant. Then m1 is the mass of the man, m2 is the mass of Mars, and d is the diameter of Mars. And so we need to find those. And then if you go on to table 8.1, here it is given right here, 3.4 times 10 to the 6 meters, and the mass is 6.42 times 10 to the 23. So we got those. So what we have to do with this equation, because we need to find the mass of the man, is that we need to rearrange this equation so m1 is on the left side of the equal sign. And so if you go and do that, you got force over d squared over g, big G, over the mass of Mars. And so all we need to do is just put in our numbers, and then get our calculators as 281 times 3.4 times 10 to the 6 squared, and over 6.67 times 10 to the negative 11 times 6.42 times 10 to the 23rd. And then you get those numbers, you get it into your calculator. We got 75.858333, and it keeps on going. And then to get the right number of significant figures is we have two significant figures right here, so our answer needs to be 2, so 75 kilograms. And then just to double check that our units in our equation is right and we've done everything right, I like to just work out the units by itself. And so at the top right here we got newtons meters squared, so that's that right there, and on the bottom newton meters squared over kilogram squared, that's this part right here, and this kilogram right here is that right there. And so the first thing that we're going to do is reduce or get rid of these kilograms. So this kilogram will reduce with this one, so we're only left with 1 kilogram on the bottom. And then so we've got newton meters squared on the top, newton meters squared over kilograms on the bottom. So we're going to rearrange that. So it looks like this. So the newton meter squared becomes this part right here. We're going to times instead of divide. And then the kilograms comes on top. Newton meter squared comes on the bottom. And then we're going to do some canceling. Newton meter squared here, Newton meter squared there. It cancels. We're left with kilograms. And that's what we want, is we wanted the mass of the person, and that's in kilograms. So we did this correctly.